Ever wondered how devices communicate over the internet? How does your message reach your friend's phone from yours, almost instantly? It's a fascinating process, with countless bits of data flying through the air, traversing vast distances in mere milliseconds. This seemingly magical process is made possible by a host of technologies and protocols working in harmony. But at the heart of it all, enabling this dance of data, is a concept as fundamental as it is powerful: the concept of sockets. So what exactly are sockets? Well, they are the heroes behind the scenes, enabling network communication between devices. To be more precise, in the sphere of internet programming, a socket is the endpoint of a bidirectional communication channel between two programs running on networked computers. Now, these sockets could be handling data flows just within your local machine, or spanning across a local network, or even darting through the vast expanse of the internet. In the realm of network communication, sockets play their part in the context of a client-server model. Here's how it typically goes. A server is all ears for incoming connections from clients, and it does so on a specific IP address and port number. Now let's talk a bit about the types of sockets. You have stream sockets, also known as TCP sockets, that use the Transmission Control Protocol. TCP ensures that data arrives in sequence and error-free. They're like your reliable postman who ensures your mail arrives intact. This makes them ideal for applications where data integrity is paramount, such as web browsers and email clients. Then you have Datagram Sockets, or UDP sockets, which utilize the User Datagram Protocol. UDP is a bit of a maverick. It's connectionless and doesn't guarantee that packets arrive in order or even at all. But what it lacks in reliability, it makes up for in speed. This makes it perfect for applications where speed is crucial and occasional data loss is acceptable, like video streaming or games. A socket address, on the other hand, is a unique identifier for a socket on a network. It's like your home address, but for a socket. It's a combination of an IP address and a port number. For instance, a web server might be listening on IP address 192.168.1.1 and port 80. Most programming languages provide a library or API for working with sockets. Python has the socket module, Java has java.net.socket, and C/C++ typically use POSIX sockets. In essence, sockets form the endpoints of a bidirectional communication channel between two programs. They are the unsung heroes that make network communication possible, enabling our digital world to function seamlessly. Now that we know what sockets are, let's delve deeper into their working and types. So sockets come in two main flavors: stream and datagram. Stream sockets, also known as TCP sockets, are the trustworthy ones. They use the Transmission Control Protocol to ensure that data arrives in the correct order and without errors. This makes them the go-to for applications where data integrity is non-negotiable, like web browsers and email clients. On the other hand, Datagram Sockets, or UDP sockets, are the wild cards. They employ the User Datagram Protocol, which doesn't bother with the niceties of orderly data delivery, or even guaranteed arrival. But what they lack in reliability, they make up in speed. This makes them perfect for applications where speed is paramount, and a bit of data loss isn't a deal breaker, like video streaming or gaming. Next up is the socket address. This is a unique identifier for a socket on a network, and is a combination of an IP address and a port number. For example, a web server might listen on IP address 192.168.1.1 and port 80. Then we have the socket API. Most programming languages have a library or API for working with sockets. Python, for instance, provides the socket module. Java has java.net.socket, and C/C++ typically use POSIX sockets. These APIs allow the creation and manipulation of sockets and provide methods for sending and receiving data. They abstract away the nitty-gritty details, making it easier for developers to focus on crafting their applications. These components together make up the backbone of communication over the internet. So, to sum it up, sockets are the secret sauce that makes network communication possible. They are the endpoints of a bidirectional communication channel between two programs, and their type, address, and API together dictate how this communication happens. Whether it's a reliable data transfer with TCP, a speedy exchange with UDP, or a unique identifier in the form of a socket address, understanding these elements is crucial to mastering the art of internet programming. So, how do sockets work in a typical client-server application? Let's break it down step by step. We'll start with the server setup. The first step for the server is to create a socket. This is accomplished using a socket API, which is a set of commands provided by a programming language to help manage the process of creating and working with sockets. Next, the server needs to bind the socket to a specific IP address and port. This essentially sets up the server's endpoint, or its specific location on the network. The server will use this endpoint to listen for incoming connections from clients. Once the socket is bound, the server can start listening. When it listens, it's essentially waiting for a client to initiate a connection. This is a bit like a telephone waiting for someone to dial its number. When a client does attempt to connect, the server needs to accept the connection. This creates a new socket that will be used for the actual communication between the client and server. The original socket continues to listen for more connections, while the new socket is used to send and receive data. Now let's switch to the client setup. Like the server, the first step for the client is to create a socket. Once the socket is created, the client needs to connect to the server. It does this by specifying the server's IP address and port number. If the server is listening on that address and port, it will accept the connection and a pathway for communication is opened. Once the client and server are connected, they can start transferring data. They send and receive data over the network using their respective sockets. This is much like having a conversation over the telephone. Finally, when the communication is over, both the client and server need to close their sockets. This terminates the connection, much like hanging up a telephone call. And voila, that's how communication happens over the internet using sockets. Opening. Now let's look at a practical example of how we can use sockets in programming. Let's consider Python, a popular language for network programming, largely due to its simplicity and the available socket module. We'll create a very basic client-server application using TCP sockets. First, we need a server. Here's a simple server script. We start by importing the socket module. Then we create a socket object and bind it to a host and port. In our case, we're using the local machine as the host, hence we use localhost. The port number is arbitrary, but it should be over 1000 to avoid conflicting with existing protocols. Let's say we choose port number 3000. The server then goes into a loop where it waits for a client to connect. When a client does connect, it sends a message to the client and then closes the connection. Next, we need a client to connect to our server. Here's a simple client script. Again, we import the socket module and create a socket object. The client doesn't bind to a port, it just connects to the server's host and port. Once connected, it receives the message from the server, prints it out, and then the connection is closed. This is a very basic example, but it illustrates the key steps involved in socket programming. The server creates a socket, binds it to a host and port, and listens for connections. When a client connects, the server sends a message to the client, then closes the connection. The client creates a socket, connects to the server, receives the message, then closes the connection. Remember, this is just the tip of the iceberg. There's a lot more to socket programming, including handling multiple connections simultaneously, error handling, and security considerations. But hopefully this gives you a good starting point. Closing. And there you have it. A simple program using sockets to communicate over the internet. So there you have it. That's a crash course on sockets in internet programming. Over the past few minutes, we've delved into the world of sockets, the unsung heroes of network communication. They serve as the endpoints of a bidirectional communication channel, allowing data to flow seamlessly between two programs running on networked computers. We've explored the two main types of sockets, stream sockets and datagram sockets, each with its unique characteristics and use cases. Stream sockets, with their reliability and connection-oriented nature, are perfect for applications like web browsers and email clients, where data integrity is paramount. On the other hand, Datagram sockets, with their speed and connectionless protocol, are best suited for applications like video streaming or games, where a bit of data loss here and there won't ruin the experience. We've also touched on the concept of a socket address, the unique identifier that distinguishes one socket from another on a network. And let's not forget about socket APIs, the tools that programming languages provide to work with sockets. Sockets impact the way we interact with the internet every single day. They underpin everything from simple network utilities to complex web servers and real-time communication services. They are the silent enablers of the digital world, facilitating the flow of information across the globe. Whether you're a seasoned programmer or a curious learner, understanding sockets is crucial for manipulating data flows over the internet. So, keep exploring and happy learning.